Hello all, welcome to another video on my channel. And today we are going to learn one important concept which is you can say backbone of calculus. So we are going to learn about limit. So what is limit, how it is useful, and how to find limit, everything we are going to discuss today. So let's just start looking at the content. So first of all, what is a limit? So limit, when we say you can consider that limit is basically a kind of value of the function when it goes near a particular specified value. So suppose we are think about it that like there is a edge of the valley, and we want to see like how the valley looks like when we are near to edge, not exactly like we are inside the valley, but like we are on the edge. So in the similarly on the in the calculus, when we want to know what is a limit, so limit is basically defining the function value which is very close. You can say the infinitely closer to the specific value, but not exactly that value. And this is how we are going to write limit, and how it read it when value of function x is L when x is approaching a. When we say x is approaching a, it means like it can approach from the left or right. In both cases, the value is going to be L only. Then only this limit, we call it limit, is defined at that point. And sometimes it happens that you'll notice in the example that at x is equal to a, this value does not exist, but very near to that the value exists. So let's go to next with the example. So in example, let's see there is a graph of y equal to x square minus x plus 2, and here if you look at when we are approaching this 2, when x is equal to 2, what is value of y? The value of y is given here 4. If we come from the right side also, suppose its value is x is equal to 3, then x is equal to 2.5 or 2.1, then also the value is going to be 4. So in this case, the limit of this function fx is 4 at this point. And in a tabular format also we can look at this. So let's take that if x is equal to 1, then what is going to be value of this? If x is equal to 1, then this is 1, and this is 1, and this is 2. So this is 2. If you go further, like if it is 1.5, then it's 1.5 square minus 1.5 plus 2, which gives me 2.75. Similarly, if you go to like 1.999, then value is going to be 3.997. This is on the left side. If you come from the right side, let's take that this value is 3. So in that case, it's 9 minus 3 plus 2, which gives me 8. But if you go closer to value of 2, in that case, again the value is almost approaching to 4. So that's why this limit is 4 in this case. 4. Another is how to find out limit. So there are different ways of finding limit. We have lot of formulas also, or the laws, limit law, we call it limit law. For now, like there are two important ways we can find out. One is numerically the way we saw in the previous page, right? So previous page, like, so here we can define through table. So and we can suppose we want to find out at x is equal to 4, let's start with maybe 3, or like go closer to 4 slowly and then see what is the value coming. Similarly, from the right side we have to go little higher than this number, whatever limit we are trying to find out, and go closer to this one. So if values both are matching, which is in this case if you look at is 0.25 is the closest value from the both, so that's why this limit is going to be 0.25. Another way of numerically finding out this one is that in this special case, we can multiply with x plus 2, x top and bottom. So what happens? In that case, on the top, if you look at, it becomes x square minus 2 square, and at bottom it becomes x minus 4, and we can leave this one, x plus 2. So this becomes x minus 4, x minus 4, and this is x plus 2. So this can cancel. So what is left is 1 over x plus 2. Now if you plug in that value, x is equal to 4, so this gives me 1 over 2 plus 2, which is 1 over 4, equal to 0.25. So this is another way of finding out. Another option is going through graph. So in this case, we first draw graph, and then we look at the value. What is the value if we approach from left side and the right side? In this example, when x is approaching 0, then value is going to be infinite. But look at the value when x is equal to negative infinity. Look at this, it's almost touching this line, x-axis. So y is equal to almost touching 0. Similarly, if I go to x is equal to positive infinity, in that case also the value of y is going to be 0. So that's why limit of 1 over x when x is approaching infinity is 0. When similarly, when x value of 1 over x when x is approaching negative infinity is also 0. So this is another way of finding a value of limit. So not in all cases limit is possible, and some cases it's not possible to find out. What are those cases where it's not possible? So one is where the function is defined in this way, where if the value is less than 0, then value is this. If value is greater than 0, greater or equal to 0, then it's 1. In this case, we cannot have definition of limit when t is approaching 0, because at this point we have two values. One from the left side is 0, and when we are approaching from the right side is 1. So in that case, we cannot define limit. Another scenario where the limit is not possible is when it's tending to infinity. So in this case, if you look at x is approaching 0 and function is 1 over x square, the graph is like this. So in this case, if approaching x to 0, then it's going to infinity. Infinity, if you notice, some people might say that okay, say in both sides value is infinity, so limit is infinity. But infinity is not a number. It's not a definite number. So that's why this limit is not possible. Now, another thing, important thing in this calculus is continuity. What is continuity? We always with terms like limit and continuity. So limit, we saw that when there is a value of the function at a specific point, when we are approaching a point, then that is called limit. Continuity is basically whether this graph is continuous or not. In the previous example, whatever we saw, right? So if you look at, if I travel from here, then without lifting my pen, I can traverse through this point. So this is called continuous or continuity. And there are three important conditions for this continuity to happen. That at this point, f into f, at a specific point, value should exist, and limit should exist here, and the both should be equal. Fa should be equal to limit of fx at x is approaching this a. So this is in brief like details about limit and continuity. I'm going to upload more videos in the following session, where we are going to look at different limit laws and how to calculate on what is the uses of limit. So please stay tuned and subscribe to my channel if you like it. Thank you.